online lecture series of Engineering Mathematics 2. Today we will just continue the next topic of gamma function. Previously we already saw the definition of your gamma function and one standard property of gamma function and some example based on that properties. So we will recall the gamma function definition. The gamma of your n plus 1 is equal to integration 0 to infinity e raised to minus x raised to n dx, wherever the value of your n is greater than 0. If the index of your x is 100, then we get gamma of 100 plus 1. If x index is suppose 2, so we get gamma of 3 is the solution. What happens when the example is in the form of the index of your exponential function is changed, but is not when we compare with the gamma function definition, the x raised to n terms is as it is, but the index of your exponential function is changed. Instead of minus x here, minus times x raised to m is here. So we have to find such a particular integration by assuming the given integration is equal to I. When we compare with our standard definition, the exponential function index is changed. So we have to convert this exponential function index into the variable of your integration. So we have to put x raised to m is equal to some parameter. So we put x raised to m is equal to t, taking 1 upon nth power on both the sides. So we get x equal to 2 raised to 1 upon m, and differentiating these x terms with respect to any another variable. So the derivative of your x is dx, the derivative of your t, whose index is 1 upon m, is 1 upon m t raised to 1 upon m minus 1 dt. This is the derivative of your t raised to 1 upon m. And changing the limit of your integration as t x going from 0 to infinity, at the same time the value of the parameter or the variable of new integration is changes from 0 to infinity. So we have to change the integration. So the given integration is here. We have to change the value of your x raised to m and value of your dx and the value of your x also. So first we have to change here x raised to m. X raised to m is changes to t raised to n upon m, because the value of your x is 1 upon t raised to 1 upon m. When we just take the index of your this x is n, it becomes t raised to n upon m. So we got this value. Then e raised to minus x raised to m becomes e raised to minus t, simply replacing the value of your x raised to m. So we get this, and the value of your dx is equal to 1 upon m t raised to 1 upon m minus 1 dt. So we have to make the change. There are two terms that containing t. The first term, the index of your t is n upon m, and second terms in which the index of your t is 1 upon m minus 1. And this 1 upon n is constant. We are taken outside the integration. So 1 upon m, integration 0 to infinity, e raised to minus t, and we have to add the index of your t's, that is n upon m plus 1 upon m minus n. So we added all the index of your t. When we compare with the definition, we have to add 1 in the index of your t, and we have to replace that term in gamma. Before, we are just using the definition, the n upon m plus 1 upon m in the both the ratio, the numerator is same, so we have to add your numerator. That is n plus 1 upon m. By definition, we get the final solution. We have to add 1 in your t's index. So we said that here minus 1 is my original terms. It is the index of your t. we have to add 1 in this, so we get a final solution. This is the definition of your gamma function. And lastly, we said that this becomes plus 1 minus 1 get cancelled. 1 upon m, n plus 1 upon m is the final solution of this example. This is the in general, the value of your m and n are anything. Some real number, some positive integer numbers. Depends on that, we can find the solution. So we will see one small example based on this property. So first, when we compare with definition, the exponential function index is root x. So we have to convert the root x terms. We know that root x can be expressed, that is a 1 by 2 index. This is the fourth root of x, can be represent x as to 1 by. So we have to put x as to 1 by 2 is equal to t. So we put it the value for x equal to 1 by t. Then squaring on both the sides. So x equal to t square. Then taking the derivative of your x is equal to dx. The derivative of your t square is 2t into dt. And the limit of your integrations, there is no change in your integration. When I change the value for x equal to 0, t becomes 0. When I change the value for x equal to infinity, the t also becomes infinity. So the limit of your integrations, there is no change in that limit. So we have to just put the value of x as to half, x and dx now in given integration. This is the integration in which we have to replace the value of x as well as dx and exponential functions in x. So the value for x is equal to t, so it becomes raised to 1 by 4. T square raised to 1 by 4. E raised to minus root x. Root x means is its index is suppose half. This is actually this is the terms. The index of exponential function is x raised to 1 by 2. So value of your x raised to 1 by 2 is equal to t. So we have to replace here. And the derivative of your dx is equal to again 2 times dt. We are replaced here. In this particular example, there is a 2 is a constant. We have to choose outside the integration and we have to just add all the index of your t. So our example reduced to 2 outside integration, t raised to 3 upon 2 is the addition of your t square raised to 1 by 4 and t raised to 1. T square raised to 1 by 4 is your 1 by 2. T square raised to 1 by 4 is 1 by 2, and this 1 by 2 plus 1 becomes 3 by 2. When we compare with the definition, see as definition of your gamma function, index of your t is n, means we have to add 1 in your gamma n. So we get the gamma function's value. The index of your t is 3 by 2, so we have to add 1 in that, 3 by 2 plus 1, and we know that 3 by 2 plus 1 is equal to gamma of 5 by 2. And gamma of 5 by 2 can be solved by using the property gamma of n into n minus 1. Gamma of 1 is equal to n minus 1 into gamma of n minus 1. We have to use this property. And we know that the odd number upon 2, we are using that. So 2 to get cancelled, we get a final solution, that is a 3 root pi divided by 2. Same example can be solved by using the standard property. Same example can be solved by using the standard property, and we have to use the standard property here. First, we have to assume the given example equal to I, changing the in terms of index x is to 1 by 4, x is to 1 by 2, and we know the standard property of this is standard property. The value for n is equal to 1 by 4 and the value for m is equal to 1 by 2. Simply replacing your m and n in this. When I compare, we get a value for n is equal to 1 by 2, 1 by 4, m is equal to 1 by 2. Replacing these two values, 1 upon 2 into 1 by 4 is the value for n plus 1 upon 2. After simplification, we get the final solution. There's 2 times. 2 times. This addition is 5 by 4. This is 1 by 2. And lastly, after simplification, this is the solution. In this way, we can find the solution of such a type of example. Thank you.